Bohuslav Šimek, standing before you, will now ask us two key questions. Do you have a need for speed, and will you pay him? If you need speed, use PHP. After all, it's a pretty fast environment, especially since version 8. But sometimes, that's not enough. Nowadays, there are tons of ways to implement numerous optimizations and speed up your code. Let's take a look at all of them, and most importantly, examine their costs. We are in for an exciting journey from PHP through C and Rust to assembly. But don't worry, we don't need to master these languages. One thing is sure, you'll be amazed by the results. Oh, and the second too. We don't have to pay him. It was a joke. Bohush, continue, please.
What an introduction. I'm afraid that it will be more fluent than my talk, but the bar is simply too high, Okay, so welcome to my talk, Need for Speed. Are you ready to pay the price? As my friend told me, I don't know this installment of Need for Speed, So, unfortunately, this is the only picture of car which we have here. This talk won't be about the cars or any video games. Okay, a few information about me. I know that I'm standing between you and the party. But let's make it, and it will be great. Okay. I work as a lead developer in PeoplePass. I'm working there for 10 years, so I'm kind of a part of company, part of the building itself, as they used to say. But I'm also a PhD student. My main focus is the performance improvement of scripting and dynamic languages, such as, for example, PHP or JavaScript. I am also a contributor to a few PHP magazines. My main point is usually the communication with C or some inner stuff, so these articles tend to be rather technical. And I have 25 experience in programming, so I actually screw up a lot of the things, and I didn't give up. Okay, just quick information about my work. As I already mentioned, I am working in the PeoplePass. We have something which our marketing called a complex NTR solution. Our main targets are Fortune 15 company. You maybe know some of them, such as, for example, SAP, Deutsche Bahn, or AWS. I love to talk about that, but this talk is not about all of this stuff. But after that, I will be there, so let's grab a beer. And I have a lot of the interesting information how to actually use the PHP in the enterprise environment. Okay, but to our main topic. I am reasonably sure that probably everybody encountered the issue that the project is kind of near, the deadline actually, not the project itself. And the performance of your project is kind of abysmal. It's poor, it's kind of slow. Okay, what to do with that? This isn't something good, of course. Usually as a programmer, you kind of have three ways how to deal with that. You can try to do some micro-optimizations. You kind of believe that small changes will change simply everything. Or you will focus on some model, and you will try to improve that model. We can call that a macro-optimizations. Or you decided that you want to do some architectural changes. Well, this is extremely hard, especially at the last minute. For example, decided you want to use a completely different database. Oh, I no longer love MySQL, I really need to use the Elasticsearch, for example. And if you decided to do this a few days before you need to finish the project, well, this usually does not work. Developers kind of tend to love the micro-optimizations because let's be honest, we are kind of lazy and we kind of believe that this will save us. Or we want to be that true. Okay, but let's show it on something, cannot say real, but something which is at least a piece of code, So the question for the public, I know that this is not in the PHP or in the JavaScript, but can somebody guess what it's the purpose of this piece of code? Exactly, it's really copying of the array, and now I will kind of show the signature. This piece of code is actually written in C or C++, which you can find out because it does not look like a PHP, and there are a lot of the funny characters, such that asterisk before the to or before the from. And you might ask yourself, is there any way how to actually make this faster, or is there anybody who actually have a problem with this piece of code? And for that, we need to travel back to 80s. Into American 80s, to be frank. And of course, this is a time traveling, and we need the rules from time traveling. So what happened in 80s, stay in 80s. You know, this is the rule for the next few minutes and slide. You know, it's like in Las Vegas. What happened in Las Vegas stays in Las Vegas. Okay, and in the 80s, in the Los Angeles, we actually meet the Duff. Duff have a problem, or, well, let's say challenge. He's working for Lucasfilm, particularly for their computer research and develop division. This is the future of Pixar. So you can kind of find out what they are actually doing. So it's a lot of the 3D stuff, animation, and things like that. And he has a timeless problem, actually, that the computers are slow. To be frank, computers are always slow. And he actually needs to copy the array quite often. I know, a little bit strange, but yeah, this used to be a type of problem back in the 80s. But fortunately, he is a wizard. He knows how to do the stuff. And he came with something which called Duff device. And, well, it's a little bit strange, to be frank. Every time when I see it, I kind of freeze. Because it's kind of strange, you know. Well, everybody knows what switch and do loop actually doing. But now we can see some, let's be frank, unholy combination. So we have a switch which is kind of jumping into the middle of the do loop. Interesting. Fortunately, this does not work in PHP, only in C and C++. So it's a really strange construction. Just one quick question. If you ever find out this in the code review, will it pass, or will you write at least something? Ask author what is actually doing this. Let's be civil, strange piece of code. Okay, and actually this is the application of concept of loop unrolling, because loops tend to be rather expensive. And by that I mean that the initiation of the loop and kind of the looping mechanism itself used to be kind of expensive. So one of the ways how to fix this was to actually duplicate the code and do this in the batches. In this case, the batches are divisible by 8, you know, and the code on the right side actually is faster, or was faster, to be frank. And the question is why there is that damn switch-do combination. Well, there is only a reason for that. If the array won't be divisible by 8. So thanks to this combination, the array can have a whenever size, you know. So great. Duff, he was in a special position. He actually needs to really speed up something. He actually knows how the CPU works internally, because to actually realize that this will speed up something, you need to know how the processor is working, you know. And he also knows how compilers work internally. Because that feature of C, that combination of switch and do loop, that was not something which was introduced into C with that goal in mind, you know. But now it's time to go back to the future, you know. We are no longer living in the 80s. You know, CPUs are much faster now. They have a better optimization, and actually same is true for compilers, you know. And the approach which Duff uses is kind of suboptimal today, you know. Actually, this will break a lot of the optimization in the modern compilers. So what happens in 80s actually can stay in 80s, and something should not be taken from 80s, as we can, for example, see, you know. But still, the Duff device can provide us some very important information about the micro-optimizations. You kind of need to know how the things are working internally, because if he didn't know how the CPU was working internally, he never came with that. They can be actually time and implementation specific. So what used to work back then does not work anymore, for example, and they can look bizarre. Okay, but now for something a little more practical, but still connected with micro-optimization. So we have here the 1 billion round challenge. And the objective is rather simple. We want to calculate the stats from the file which has 1 billion rows. And in that rows, we simply have the name of the weather station and temperature. That's it. That's all. This challenge originally has been done in Java. Of course, the other languages, other programmers kind of join it, and they try their own solution in their own languages. In PHP, this has been mainly done by Florian Engelhardt, so many of the next examples are kind of based on his code. I'm forever grateful for that, and I'm really looking forward to that because, well, these are the excellent examples of micro-optimizations and how they can actually affect the execution time. Okay, so what we want to do, we want to print minimum, mean, and maximum temperature per station, and it must be sorted alphabetically. A few information about the measure methodology, no mythology. Sometimes methodology is mythology, but that's a topic for completely different talk. We will be using the wall clock for measuring the time, so we actually won't use the number of CPU cycles. We will do this on Linux, because this can have a potential impact. And also, results will be different across the hardware. So I actually did my measurement on the ThinkPad laptop, not on this one. And of course, the other measurement, if you do this on your own hardware, it can be a little bit different. And same, for example, go also for the version of PHP. And what we will also do, we will kind of flushing some internal caches after each run, because if we didn't do that, something will be cached still in the memory. Okay, so here is how we will do it. It's rather straightforward. We have some array in which we will put all values. We will simply open the files. Then we use the fget CVS function for kind of getting the raw and parse it. If we don't have any weather station, we will create the value in the array. We will set minimum, maximum value. You know, we still don't have any data, so we can do it kind of simply. If we already encountered the weather station, we will simply increment the counter, add the value to sum, and then update the minimum or the maximum value accordingly. Then after that, we will sort that array, and we will print our results. We will calculate the average value. So then we have our results. Great. Okay. So we will start with setting up our baseline, and it will be, on my computer, it was around 200 seconds. I would say not great, not terrible, but to be frank, it's kind of slow. Okay, and the first step is in our optimization to don't change anything. So what we will do, because we are running this benchmark from the command line, we kind of forget that the opcache and the JIT engine is not turned on by default. So we will turn this, and we will actually save around 50 seconds. This is not much, you know, but it's honest work. Especially if you already have a JIT engine and opcache, you know. If I was forced to implement the JIT engine just for that, I won't be so happy, of course, you know. So very important things, opcache by default is not enabled for command line. And you know, in the IT, it's kind of hard to actually name the thing properly, because the opcache is not only for caching the things, but it also has a few optimization passes, and actually the JIT engine is also implemented as a part of opcache. So very important thing. And the next thing which we want to do, we will replace the fget CVS function with plain old fgets and with the parsing things by hand. We can actually do this because we are in the full control of our input data and we know their format. So this would kind of work for us, and it will be faster by 65%. So we are now around 30 seconds, you know. And the issue here is that fget CVS actually do more things than we needed in this particular case. So we don't need that stuff, you know, especially when we are in control of the input file, as we are in this challenge. So great. Another optimization which we can use is, are references, actually. References are not a magic tool, but in our case, we are kind of often putting something into the array, into rather big array after reading the few lines. So it will be better to not so often ask the PHP array where is the value and things like that, you know. So we will use references for that. It's a little bit faster, around 6%. Yeah, it kind of nothing big, but still can be useful. We kind of saved all the array accesses. There can be, after the talk, there can be huge debate how this actually working, this internal and things like that, but let's keep this for later. Okay, then we can realize that we have some form of extra compression there, because the temperature, if we already collect at least one of the weather stations, the next row with weather station, the value can be min or max, but it cannot be min and max at the same time, you know. So we can kind of remove or actually merge two ifs into if and else if. Great. So it's faster by 9% just by doing the extra operation. Great again. Another thing, because again, I have to stress this enough. We are in the control of our file, and we know that all values inside there are simply the float values. So we can directly typecast the value. And this is extremely surprising, because it will be faster again. So we are now around 160 seconds, and the reason for this is that we actually kind of hint PHP that the value will have a particular data type, and some optimizations inside of the PHP, they no longer need to determine the things dynamically, and it can be a little bit faster. Great. Okay, then I will, you know, the replacement of fget CVS with fget was a huge success for me. So what did I use the explode instead of combination of strpos and substr function? Maybe this will be useful. That doesn't work. Interesting. I didn't find out why it doesn't work. It doesn't make anything significantly faster, but at least it wasn't slower. So at least something, you know. Then I was starting to be a little bit frustrated, and I decided that there is a time to actually rewrite the file access and to use my own extension in C. Yeah, because, well, you know, again, the reading from files in PHP, they need to implement the streams and a lot of the other thing. So I did it. Well, it wasn't a success. Of course, I removed a lot of the unneeded things, but it was still slower. By 20%, around 20%, to be frank. And my solution was extremely naive. You know, I just try it, and let's see it. You know, some low-hanging fruits, you know. Okay, so I kind of need to redesign my extension for the peak performance, you know. So it took me 2 days. Read a few informations about what is the efficient way how to actually read the data from the file system on Linux. Very important information. And I realized that there is the possibility to use mmap, which will kind of map the file directly into memory. And when I did that, I reached the virtually same performance. And I was kind of happy about it, that at least the performance was the same, you know. That was a huge success for me as for someone who is kind of a geek, but the real impact, it wasn't good. And one very important thing, from that moment, I kind of have one big binary blob in my code, and I was virtually only person who kind of understand it, you know, at this moment. And especially if you have a team full of PHP developers, and then something came, you know, who will actually maintain it? And if there will be any bug with that, you know. Okay. So if you don't know what to do, you will look into the other contestants in 1 billion RAM challenge, and you will quickly realize that almost all of them are using the parallelization. Fortunately, in PHP, we have an extension parallel. And extension parallel, well, it's kind of mumbo-jumbo. It allows you to using the thread support in some constraints manner. It's using a CSP model, you know. Basically, at this moment, this does not mean anything, because this is the only available extension to actually use the parallelization with the help of threads in PHP. So let's stick to it. And again, it was faster. And with the 20 threads, I reached, my final time was around 30 seconds, you know. But I actually needed an extension. That was a little bit problem, and I need to rebuild my PHP. So it was a little bit bad, because for that you need to have a Zen-thread safe PHP build. And of course, then you need to then all of your extensions actually need to support that mode of PHP. So if you have some exotic combination of extensions, you're kind of screw up. Okay. So what if we ignore almost all that I present to you, and from the second version with fget, we skip all the steps and we directly do the parallelization. And yeah, it won't be 30 seconds, but it will be around 65. Well, which is still rather good. You know, and this represents more architectural change from beginning, you know, and what is kind of good, in this case, the parallelization was rather simple. In some other cases, this probably won't be so straightforward. Okay, so now it's the time to address the elephant in the room. In the PHP conference, there is always elephant in the room, and this is how PHP compares with others. So I did the same measurement on my computer again, of course, with a solution in Java. What is kind of interesting, their baseline solution take around 2 minutes, so 130 seconds. So it was slower than our final solution in PHP, so at least something, you know, kind of great. This fastest solution was 5.2. And it was submitted by the architect of new Java virtual machine, and he virtually spent last 15 years of his life to make Java as fast as possible. So, well, we possibly cannot measure to him, you know. I also find some solution in C, because, to be frank, I was too lazy to actually do it by myself. And it was a little bit interesting, because it was a little bit slower than the fastest Java solution. Just marginally, you know, but that solution in C was not so efficient. And in PHP, it was around 30 seconds, you know. Okay, so you can see that sometimes it can be useful to actually use another programming language, you know. Maybe if we combine the both from the best from the both words, you know, maybe this will work. Okay. So for example, if I really want to have some fast calculation of cosine similarity, okay, there is a formula. Is there anybody who actually understands it from the formula, what it should be done? You have the same reaction as me, always when I saw it. Okay. Actually, when you write down in PHP, it looks like that. So all of these, at first sight, complicated parts of formula can be actually transferred into something like that. At this moment, it's not so important what is actually, there is no need to actually explain you every line here, you know. What is more important is that this is just a pure calculation. There is no access to I/O or anything like that. So I can clearly see that, for example, JIT engine will make a huge difference here. You know, it's just a little bit hint. Okay, so I actually try to re-implement this algorithm in multiple ways. I did a benchmark on 3 datasets. I call them small, middle, and big, but in reality, all of them are kind of small, you know. And I was using that cosine similarity algorithm on two arrays. And I actually didn't mention the main reason for this algorithm is to calculate how much these arrays are same. And I actually believe that during the talk about the artificial intelligence, someone was already talking about that algorithm. So you can actually find it now in the embeddings. So, and I decided to write it in a pure PHP, then in some functional PHP, which is kind of a parody of functional PHP, to be frank. I also used the FFI, so I did the solution in the pure C, and pure C, not pure C, and then I call it with the help of FFI. So FFI is a mechanism in PHP which allows you to call directly C code, or things compile into C. Then I did a regular C extension for PHP. I did the same in Rust. And last but not least, I also use the assembly. I didn't use my grandmother assembly, but a modern variant called SSE. And well, this is my funny functional version, and it's functional only because I am using array underscore something function. So it's a borderline parody, to be frank, you know. If I really want to do something functional, I would probably switch the language, and if I actually want to have at least some compatibility with PHP, I will use the FEL, which is the implementation of functional language like Clojure, but built on the top of PHP. So if you really want to try something fully functional, let's say, and you still need to integrate this with PHP code, give it a try. Then I have a C version. What is kind of interesting about the C version is extremely similar to PHP version, in a way that it's a simple mathematical algorithm, you know, so virtually it will be rather the same. There's nothing extra. Extension looks kind of similar. There is actually a lot of the boilerplate code. And many lines. It's not even possible to actually put it into the slide, obviously. In the case of Rust, it's much better because we have a special library for that, which is kind of excellent. So this is a whole Rust extension. It's kind of small, and everything which is not highlighted is the implementation in the Rust, and the rest is actually the boilerplate code, which will create it from the PHP extension. So there is simply some marshalling, and that's it. You know, it's simple. Well, in assembly, it starts to be a little more complicated. I actually use, they used to be special, now they are not so special, but some instruction in assembly which can handle more data at once, you know. And this is not threading, but the modern processors can actually do multiple instructions at once. So I did that, I prepared that. There is one very huge issue. My code won't work, or natively won't work on ARM CPUs. So for example, M1, AWS Graviton, my code simply won't run. I will need to actually emulate it, and it will be significantly slower. And the question is, isn't this kind of pointless? You know, it's a poor calculation, so maybe the compiler will do the same for me. Let's see. So this is just for the reference, the portion of implementation. Nowadays, fortunately, we don't need to write assembler in hand, but we can actually combine it with C. So in this case, it was a little bit cheating, you know, not like that 10, 20 years ago, and this was simply not possible. It kind of does not matter what this means. I am reasonably sure that it's kind of, it doesn't make any sense at the first sight. It always took me a lot of the time to actually realize what each of the instruction is doing. Okay, so who wins? And now it's the time for your bet. Who do you think actually wins? What is the fastest solution? Assembly I heard here. Did I hear Rust? Rust, yeah, this is a common answer. Just one very quick question. Did you ever see any benchmarks of Rust and how it compares with the rest of the languages? That's a very interesting thing, but we can discuss this later. Okay, so actually it was assembly, to my huge surprise, because I had a huge skill issue with assembly, obviously. It's not a language which I am using on, I want to say daily basis, but it's even on a year basis. I was so surprised by that, so I spent almost a day to actually check it if I didn't do something wrong. Then there was a C, but the differences were rather slow. Rust was surprisingly slow, but this is actually not the reason because the language itself is slow. But the extension itself was doing some extra work, you know, some extra conversion, and I'm reasonably sure that with the next or the future versions of that extension, it will be actually faster, you know. Probably it won't be faster than C, because some abstractions in RAS will be never as fast as C. FFI was kind of surprising for me, but it's always kind of slow. PHP was kind of expecting that it will be last. I actually don't want to comment on the functional version because it was kind of different, There was few extra things, If I compare it across the sizes, the trend is there kind of same. Kind of interesting is FFI because there is the fixed price for preparing and setting up everything. So the difference with the bigger data size will be smaller. Okay, but then I actually realized one small issue. I forget to turn on Opcache and JIT-engine. So I did my measuring again, and hooray! PHP version was actually faster. Oh my god. And now I have a problem. This is my real reaction when I saw it, So it seems, the relay, Opcache and JIT-engine is really fast. And it actually really helps me. Okay, so this is kind of surprising because it's kind of a mixed bag. If you see some benchmarks, these benchmarks on the synthetic things, they usually you see a huge performance advantage of JIT-engine. But if you turn it on for a website which is using the WordPress, the gain is around 3%, so it's kind of funny, Okay, so what I did, I double-checked my C extension code, and I find one issue. It wasn't one-to-one to PHP code. I was actually doing some extra conversion from PHP array to C array. I came with the idea, what if I do it directly? So I redesigned my extension, so now it's a little more complicated, let's say, but the only thing which I actually did, I used the internal PHP functions which are used in the extension itself, and I didn't make a copy of array. PHP was still faster. I was kind of happy that this actually happens. I checked it multiple times. If there is any issue, didn't find any. Okay, but my interpretation in this, I actually drafted for my research for PhD, and mainly Oracle was playing in that role, and they quickly find out, and it's especially true for Java, that the calling the C code from some interpreted language, and Java used to be, and it's to some degree interpreted, actually introduce a huge overhead. So in some cases, it's actually better some small code write natively in that particular language. So in some cases, it's actually better to not leave the PHP. And in this case, you can maybe benefit with from JIT-engine and Opcache. You maybe ask us, okay, so should we rewrite everything in PHP? Ditch the PHP library right in the C? Of course not. There still can be things which, especially thanks to how the PHP is still deployed, it's kind of useful that a lot of the things are created in the C. Because I didn't mention one very important thing about the JIT-engine. It takes JIT-engine some time to actually kick in and provide you any measurable optimization. In some cases, it's still better that everything is in the native code. But on the other side, let's leave PHP, at least for one slide. And in Ruby, they actually gain, for a lot of the applications, some performance gain, because they rewrite their array each function, which is like, let's say, and let's simplify it, like a for each in the world of Ruby. They actually rewrite it directly in the Ruby, and they achieve a better performance. So yeah, there is some case for this, Okay, so quick recapitulation. Because as I already mentioned, I know that I'm standing between you and the beer. Micro-optimization, they can be definitely magic. It can take some time to actually understand them if you didn't see them for a long time. You must do a proper measurement. I actually didn't mention that, but all these charts that are from PHP Bench tool. And it helped me tremendously with methodological things, with repeating the stuff, with doing the warm-ups, you know. The results can be surprising, and you have to double-check it. And you must take into account, for example, the cognitive bias. Because for me, I was still thinking, OK, C will be always fastest. There is no chance that my assembly will be on the same speed range, you know, and things like that. Well, threading definitely can be hard. You know, and to be frank, I'm extremely afraid to do anything in parallel. And the reason for this are the experience from the real life, you know, because especially if you're not prepared for that, it can be extremely hard. In our case, it was a little bit easier because it was just reading, no write operation. And last but not least, double check the opcache and JIT engine. And this is also true for the production and especially for the web servers, because I single-handedly reached the biggest performance improvement for our servers. Because when we are switching from PHP 5.5 to PHP 7, we didn't turn on the opcache. We completely forget it. And as there was rather big performance gain from PHP 5 to PHP 7, we were thinking, yeah, this is all right. So it's the same as speed, OK, so maybe the PHP 7 is not as good as it seems. Then I was doing some optimization of opcache, and during the first step of optimization of opcache, I realized that we didn't use it. Oh my gosh, so it was kind of funny. Okay, so that's everything from my side. Thank you for attention. You can have questions, of course, and give you a few time for taking a photo. And of course, don't forget to rate my talk. I'm looking forward to any feedback, you know, what can be improved. Okay, so that's everything from my side. And as I already mentioned, any questions? Nothing? Well, I will be around, you know. I will leave tomorrow, so let's grab a beer, and maybe you will have some questions or things like that. Or was there any? Ah, okay. Okay, so thank you very much.